A deer is standing completely still in the middle of a winter trail. Two hikers are walking straight toward it, and it doesn't run. That's the first thing that should stop you cold, because a deer's entire existence is built around one single rule: run first, ask nothing later. Its eyes sit on the sides of its head specifically to maximize the area it can watch for threats. Its legs are engineered for explosive escape. Its heart rate can double in the time it takes you to blink. A deer does not stand still for humans. A deer does not stand still for anything. But this one did. Its head was hanging low, heavy. Ice had built up around its muzzle from its own frozen breath, layer by layer, sealing its mouth almost completely shut. It could barely see. It could barely breathe. And when the hikers came close enough to reach out and touch it, it just let them. Stood there while two strangers chipped ice off its face with their bare hands, and when the last of it fell away, when its nostrils finally cleared and its eyes blinked open, it startled, steadied itself, and bolted back into the trees. Here's the question that moment leaves behind. Did that deer know those hikers would help it? The answer the internet wants is yes. The answer most biologists would give you is complicated, and the answer hiding underneath both of those, the one that's actually sitting in the research, is stranger and more unsettling than either one. Let's build the baseline first, because without it, nothing that follows makes sense. A study published in Science in 2015 ran the numbers on how humans hunt compared to every other predator on the planet. The result was almost difficult to read. We kill adult prey at rates up to 9 times higher than any non-human carnivore. Not 9%, 9 times. Lions, wolves, orcas, none of them come close to the pressure we've historically put on every species that shares a landscape with us. And animals didn't miss the memo. Researchers have played recordings of calm, conversational human voices near wild animal populations. No gunshots, no engines, just people talking. And watched entire herds abandon their feeding grounds on the spot. Not because they heard something aggressive, just because they heard us. The human voice alone, in field experiments, outperforms lion roars as a deterrent. That is the world a deer is born into. That is the threat level encoded into its nervous system before it ever sees its first human being. So the real question was never, why do animals fear us? That part is easy. The real question is how that fear ever gets turned off at all. Here's where it starts getting strange. Because the fear doesn't get turned off randomly. It doesn't happen by accident. It happens through very specific channels, and the first one has nothing to do with emotion at all. Dr. John Marsluff and his team at the University of Washington spent years studying how wild American crows track human individuals. What they found was that these birds weren't running a simple human versus not human calculation. They were building files. Specific, detailed, long-term files on individual people. A crow that had a bad experience with one particular human face held onto that memory for over 5 years and passed the information to other crows that had never even seen the original encounter. Not humans are dangerous. That specific human, that specific face. If a bird the size of your fist can make that distinction, a deer certainly can. And research on African elephants confirmed that this kind of individual-level sorting isn't limited to birds. Elephants, it turns out, can differentiate between human ethnic groups purely by voice, reacting with measurably higher defensive behavior when they hear the language and vocal patterns of communities with a historical connection to hunting them. They weren't responding to humans in general. They were responding to the specific sound of the humans who, across generations, had been the dangerous ones. What both of those findings mean is that the animal threat system isn't a single alarm bell. It's closer to a security system with multiple scanners, checking voice, checking face, checking approach speed, checking eye contact, and making a layered assessment before deciding what to do next. And that matters enormously for what happens the moment the crisis hits. Because here's what actually happens inside an animal's body when it gets trapped. When a deer gets tangled in a fence, when its face ices over and it can't breathe, when it's been running from a predator for so long that its legs stop responding the way they should. The amygdala, the part of the brain that handles threat, doesn't calm down in those moments. It floods. Adrenaline and cortisol spike to levels that, in a human, would be associated with the worst moments of our lives. A deer caught in wire has higher stress hormone concentrations than a deer that's been shot. Higher than being struck by a vehicle. The body is spending every reserve it has on a threat response that has nowhere to go. And if that state holds long enough, if the struggling keeps failing, if the running keeps going nowhere, something shifts. Scientists call it learned helplessness. The defensive systems stop firing, not because the animal decided to trust you, but because they've run out of fuel. They tried everything the body knows how to do. None of it worked, and now there's nothing left. That's the stillness that looks like surrender. That's the deer standing on the trail, head down, letting strangers approach. It didn't choose to trust them. It ran out of alternatives. But, and this is the part that changes the whole story, that still doesn't explain why it moved toward them. Because learned helplessness makes an animal go still, it doesn't make an animal approach a human. So something else is happening on top of it. And the name researchers give it is almost brutally simple: risk triage. When an animal is in a crisis, its nervous system isn't asking a philosophical question about whether this particular human means well. It's running a comparison. Behind the animal, the thing that's actively killing it. In front, a large, slow-moving shape that is not charging, not making predator sounds, not closing distance in a straight, aggressive line. The threat system scans its entire library of predator signatures: speed of approach, body angle, eye contact pattern, vocalization type, and when none of them match, the alarm doesn't fire. Not because the human is recognized as safe, because the human fails to be recognized as dangerous. And in that narrow gap, when the immediate threat behind the animal is worse than the uncertain threat in front of it, the animal takes the exit that's still open. Ecologists call it the predator shield. It's not trust, it's arithmetic, and it doesn't require the animal to understand anything about human kindness, human veterinary capability, or human intention. It only requires that, in this specific moment, standing near a slow-moving human is less immediately fatal than the alternative. Now here's where the story is supposed to end with a warm feeling. The animal gets freed, it looks back, and something passes between two different kinds of creatures that maybe means something. But science has one more thing to say before we get there, and it's the part that almost never makes it into the viral clips. When a deer bolts the moment the ice is cleared from its face, that's not ingratitude. When a whale circles back and nudges the divers who cut it free, that's not necessarily gratitude either. Cognitive researchers studying cetacean behavior after rescue events describe what looks like affection as something more mechanical: the physical recalibration of a body that's been locked in restriction for hours, combined with sensory checking, the same way you'd instinctively touch a wall to steady yourself after sitting completely still for too long. The whale isn't saying thank you, it's relearning how to move. And this matters because the most important finding in this entire line of research isn't about what animals feel after a rescue. It's about which animals are even capable of suspending their fear long enough for one to happen. High brain-to-body ratio species, cetaceans, elephants, corvids, show this suspended fear, approach or tolerate behavior consistently. They can socially transmit learned calm around specific humans through their groups, teaching the next generation that a particular human presence isn't a threat. But apex predators, large felids, reptiles, they almost never show it. A crocodile with an injury doesn't go still and let you help. An injured leopard doesn't let you approach. Their brains simply aren't built with the extra circuitry to run a threat comparison that has more than one outcome. For them, there's only ever one loop: fight or flee. A third option never loads. Which means the capacity to receive help, the ability to be rescued at all, isn't distributed equally across the animal kingdom. It clusters, hard, in the species we already suspect of having the most complex inner lives. The ones that grieve, the ones that recognize their own reflections, the ones that remember individual human faces for years and teach their young what they've learned. So back to the deer on the winter trail. Did it know those hikers would help it? Probably not in any way that resembles what we mean by knowing. It didn't recognize them. It had no history with them. It couldn't have predicted what hands on its face would accomplish. What it had was a nervous system that had exhausted every answer it already knew. What it had was a threat comparison that came back with one option still open, and what it had, almost by accident, was a brain just complex enough to not slam that option shut. The hikers didn't get chosen because animals understand human kindness. They got chosen because in that specific moment, they were the only thing in the environment that wasn't already killing that deer. And maybe that's the part worth sitting with, because the fear never actually went away, not even for a second. The deer was terrified the entire time those hands were on its face. It bolted the moment it could. It just decided, somewhere below the level of thought, that being terrified near a human was survivable. Being alone in that ice was not.